Hello everyone, welcome to Gate Wallah. So we have a candidate Vishrut Singh today who is going to appear for the BARC examination. So we are going to conduct the mock interview for the BARC examination. Vishrut, welcome first of all and kindly introduce yourself.
Hello, I'm Vishrut Singh. Recently completed my graduation from IIT Delhi in Civil Engineering. I am a resident of Delhi and I also did my schooling in Delhi from St. Francis de Sales School. Currently, I am preparing for government exams and want to pursue a career in civil engineering.
Tell me what were your area of interest during your college days?
So, mainly my area of interest was strength of material, geotechnical engineering, and environmental engineering. These were the subjects I mainly liked, and also fluid mechanics.
Did you do cube testing?
Yes, sir.
What was the size of the cube you have tested?
So I tested 150 cube in UTM machine. So 150 of all the sides.
150 cube in the UTM machine, right?
Yes, sir.
Uh, this was for RCC?
Yes, sir.
This was for RCC. Can I
So,
make
acha, yes, sir.
cube of size 10 centimeter for the very same concrete? Does code permit me that?
Yes, sir. I guess that you can make a concrete of 10 centimeter size, but the strength will be increased. So we have to decrease this strength that we get from the UTM test accordingly to the.
Like why we are not doing it? What changes could we make to the basics of the concrete so that I can test it to 10 centimeter? Or I can test the cube of any concrete, whether it is of any size or anything, any composition. I could make it 10 centimeter cube or I could make it 15 centimeter cube. Or
the
there are certain criterias for it.
so the problem that is coming to my mind right now regarding the concrete that happens is that the smaller the specimen, the higher strength it will give. First of all, due to a very smaller size, so the failure surfaces, actually, the steel plate on the top and the bottom that we put, it imparts friction resistance to the particular concrete. So in a way, it increases its strength. So the smaller the cube, the more effect that friction resistance has over the overall structure of the cube. So the longer concrete we take, so that the friction resistance, it just stays on the top, so that we can actually find the actual load at which the concrete fails without the friction resistance increasing its strength. So the code actually made the size 150 but the prescribed sizes in normal reference books, as I read it, was the cylinder with the ratio of twice the depth to the diameter. So that perfectly, even if the friction resistance occurs, the center line is not affected by it. So the crushing that happens in the middle is purely due to the concrete strength. So if we take smaller size cubes, I believe that the strength will be quite high than what it actually will be on the field. So to remove that, we somehow have to remove the friction resistance that the steel plates offer when we are testing in a UTM machine.
What is the major difference between working stress method and the limit state method? How you can differentiate these two methods from each other, and how you can say which method is better and this method is, sir, inferior. That is why we are using this new method over the inferior
So,
one.
so I believe that in working stress method, it is mainly about elastic analysis.
Hmm.
Like the concrete is assumed to obey Hooke's law, but the limit state method does not take that into account. The strain profile is same in both the methods, as strain is actually a geometrical property of the material, but the stress part in WSM, it is assumed that the stress and strain are directly proportional to each other through a modulus of elasticity. But in WSM, in limit state method, there are predefined strengths and what stress they will bear at a particular strain, as given in IS 456. So, and another, I very much believe that WSM is a much better method, as WSM is based on a probabilistic method. LSM is based on a probabilistic method. WSM is based on a deterministic method. Like it is
Hmm.
already said that the stresses should remain within the elastic
Okay.
ranges. And one major difference that happens is like in WSM, we know the yield strength of material is measured, and only their strengths are decreased. The loads are not touched, they are not observed for their uncertainty, their increase or decrease, or anything like that. But in limit state method, there is a very profound probabilistic and statistical calculation, and loads are also factored, and the strengths are also partially decreased. So there's a partial safety factor in the loads due to their uncertainty, and also a safety factor in load in the strengths for their uncertainty. So both of them are combined to find the particular factor of safety, and this is the major difference. I very much, and in LSM we go up till the ultimate failure strength. We don't just use the objects. Like steel is a very important object in RCC. So if steel is taken to be failing at yield, then most of his strength is wasted. But if you go to the ultimate state, much of his strength is conserved, and there is the proposed structure is much more economical. So I believe that WSM is a much inferior concept than LSM.
What is the factor of safety? Let me write here. The concrete, right?
Yes, sir.
This I'm talking about working stress. This I'm talking about limit state, correct? Now
Yes, sir.
moving to this, what this is steel. I'm talking about working stress. I'm talking about limit state method. Now what I'm talking here is factor of safety. That is the load factor, or I can say, okay, you take it factor of safety in general, right? So in both the cases, what is the factor of safety overall?
So in WSM concrete has been given a factor of safety of three,
Three.
mainly, almost three. Yes, sir. So like we divide the strength by three, and we
Okay.
use that as the strength of concrete.
Okay. So you are saying it is three, correct?
Yes, sir. Yes, sir.
And case of concrete?
Yes, sir.
Okay. What about LSM?
So LSM, first there has been a reduction to from the FCKV measure at the field to 0.67, and then I believe that is 1.5 times, and then again it has been decreased to 1.15 times more, I guess. So the
Yes.
total overall, I believe it should be almost 3.3, considering a load combination of 1.5 as dead and live load.
Yeah. So you are saying it is 3.33, correct?
Yes, sir. Yes, sir.
Now moving to this steel,
So in WSM, the steel has been decreased by,
completely right.
yeah,
Are you sure?
1 divided by 0.55. So that's 20 by 11. Yes, sir. It's a very near to this value.
Okay.
What type of settling you will prefer?
So settling
Or you,
and
in indirect way, if I ask you, in that sedimentation which you are talking about, which
yes,
type
sir.
of settling will occur in that case?
So for the initial part, it will be discrete settling.
Okay.
Yes, sir. So because all the
Can you
uh,
explain the discrete settling?
yes, sir. So as the sand particles are present independently, so they don't interact with each other much. They're just present as they are. So whenever the water stops, the turbulence is less. These particles, because of their own weight and higher specific gravity than water, they all settle down at the bottom of the water. So there's no interaction between the particles, there's no flocculation, there's no intermixing of them. They just, as a single independent unit, settle to the bottom of the tank.
So to actually settle that type of particle, what actually you do in the plane sedimentation tank, the mechanism I'm talking about, what changes
So,
you have done it in that sedimentation unit so that these particle can settle down comfortably as you
so,
wanted to do?
so I believe the major change that we do is providing a higher detention time for them to actually settle down, because we have to shift that water to there's a continuous if a
But
continuous process is chosen.
giving higher detention time is the, I will say, the output or the input which you have given. The
Yes.
mechanism, because of higher detention time, what will happen with that water?
So the particles will get enough time to settle at the bottom of the tank, and we remove the water from the top. So the clear water would be up, the particles would be settled down, and the clear water would move to our next treatment unit.
Can you explain me a little bit more about this? Because I want some technical aspect of this, not general, but some technical aspect of this, like giving extra time, actually, how it will help that I'm not getting.
So like there's a particular settling velocity for the particles present in the
Okay.
water that we're using. So if we see it as we find that particular settling velocity, it is based on the diameter and the specific gravity. Depending, so what we do is that we maintain a very slow laminar flow. So these particles drift down to the bottom of the water, and now this their settling velocity with respect to the height of the sedimentation tank that we are given will decide that how much time these particles will take to settle at the bottom. Now,
Okay.
but we have to keep the water moving. So there's a horizontal velocity too provided to the particular tank. So we have to ensure that before before a batch of water reaches the end of the particular sedimentation tank, the particles completely settle down at the bottom. So their time taken for their settling velocity to cover the height should be less than the time taken for their horizontal velocity to cover the length of the tank.
So that settling which you are talking about, in that the settling will be a vertical settling or an inclined settling?
So it will be inclined, as there will be two components of velocity. First towards the right, that the water
Will
is
it be
moving.
same for all type of tank, or you are saying it general?
So only for only for the rectangular tank, so not for the circular tank.
Then what about for circular tank?
So in circular tank, as our area increases, the area of flow increases, so our velocity keeps on decreasing, but the
Okay.
settling velocity never changes. So in a rectangular sedimentation tank, as there was no change of area, there was a constant width and a constant height. So the water moved with a constant velocity over the entire length. But if
But
we,
the similar type of situation we do in our home also, na? Like we take some water, we put in the bucket, we
yes, sir.
store the water. So do you find any difference in what you are talking and what we have doing it in a home?
So like,
Any
so
change in the mechanism which you are actually quoting it, which you do in the treatment plant, but we are not doing that same thing in the home?
so I believe in home our particles will settle straight down because we are not moving our water continuously through a particular thing. We
So
don't
is
need
that you
that.
change in the mechanism? So in between like the mechanism which we use in our home and the treatment plant, which one will give you more efficiency?
So it would very much be the one we use at home because we just keep that water and we let it settle for as long as we want. But in treatment plant, we cannot usually guarantee 100% settlement as if if there are particles which are whose settling velocity, the time they take for covering the height would be more than the time the water takes for covering the length. So there will not be complete settling of those particles and they will move on to the next treatment tank for a particular treatment. And so we cannot always guarantee like 100% settlement of particles because we are not sure about all the entirety of diameters of the particles present and then the specific gravities they have. So, and even if the formula is particularly for a very specific circular sphere, and there may be a shape factor involved if we check it, but we cannot always be sure about the spent particles as we are not microscopically checking each of them.
All the three faculties have taken a very grilled interview with you, right?
Yes,
I
sir.
believe. What's your feedback?
So it was an amazing interview, sir. I did not even know that. I did not know these things. I have to study upon them a lot, like
Okay.
clear my fundamental concepts more.
आपने एक्सपेक्ट किया था कि द इंटरव्यू विल गो लाइक दिस एंड
No, sir, not at all.
अच्छा.
Sir, I thought it would have been some like basically asking from subjectal knowledge. So I was like, okay, it would be that, but it was very much into this, sir.
थोड़ा सा बेटा मैं आपको बताऊं, बार्क का जो इंटरव्यू है ना, उसके लिए यही रिक्वायरमेंट है
जी सर।
कि थोड़ा सा डीप डाउन करना पड़ता है हमें. मुझे मालूम है जब हम किसी रिटन एग्जाम की तैयारी करते हैं तो हमारी स्पीड ना बहुत तेज होती है तैयारी करने की. तो हम फंडामेंटल्स उतना ज़्यादा ध्यान नहीं देते, हमें लगता है कि क्वेश्चंस लगने चाहिए हमसे, राइट? ऐसे ही
यस सर
होता है
सर।
ना.
जी सर।
मोस्ट हमारा ऑब्जेक्टिव जो रहता है कि टेस्ट सीरीज अच्छी जानी चाहिए, क्वेश्चंस ज़्यादा से ज़्यादा लगने चाहिए, बट
हाँ सर।
फंडामेंटल्स कहीं ना कहीं पीछे रह जाते हैं.
यस सर।
और यहाँ जो बार्क है या जितने भी जहाँ पर भी आप साइंटिस्ट की पोजीशन पे आप अपने आप को देखते हो, तो इस तरीके के इंटरव्यूज में वाई का ही सबसे बड़ा रोल है.
Clearing exam and clearing BARC interview will be little bit different. अगर
जी
आप
सर।
उसको बहुत ही frankly बोलें तो बहुत different है.
यस सर।
Vast gap है इसमें.
हम्म।
With your answer, what I'm saying it, see in BARC interview, three things you should be completely in a complete right position. The first thing will be the basic. You cannot.
हम्म।
Every basic answer, if you are giving wrong now, it will be a slight drop in the impression.
यस सर।
Second thing, if you are mentioning it that something you are doing related to some projects,
हम्म।
then you should be completely ready to answer each and every why question.
Yes, sir.
At least not 100% because you have done the research in a particular field, but at least 60 to 70% you should answer.
Okay, sir.
And the fourth thing, then generally when you will not answer these things, then people will come to you regarding the subject technical part, which you have used in your GATE or ESE exam to clear that, or here in BRC also.
Yes, sir.
That means the technical part. That is the reason I shifted to the technical discussion.
Yes, sir.
But in that technical discussion, if you will not able to answer Reynolds number or Mach number, it will be a drop.
Yes, sir.
So you should be in a simple, take your notes, revise it each and every basic point.
Yes, sir.
And the third thing is the application based. So first is the, I will say, the basic concept one. Second one will be your college project, maybe any project which you are saying it.
Yes, sir.
So they will definitely go for the project part, even though if you wanted to do that or not. Like some people, they do the mistake. They have a project on structure and the favorite topic they say non-structures.
Yes, sir.
So you're basically giving a playground for them to play with both the part. They will ask you a question from structure also. They will ask you a question from non-structure also.
Yes, sir.
So especially for the environment and fluid mechanics part, if I will comment, I feel technical basic is little bit lagging.
Yes, sir.
थोड़ा सा उस पे और अपना सब्जेक्ट पे, मैंने सब्जेक्ट से बाहर कुछ नहीं पूछा है, बट सब्जेक्ट वाले पार्ट को, स्पेशली द नोट्स जो मैंने आपको बोला, दोनों के फ्लूइड मैकेनिक्स के नोट एंड द एनवायरमेंटल इंजीनियरिंग नोट्स, you have to like completely thoroughly you have to study that, and you cannot answer, again I'm repeating it, you cannot answer Reynolds number incorrectly or Mach number incorrectly.
Yes, sir.
These are the basics for you, even you are going for the fluid mechanics one or that.
Yes, sir.
Any general question, if you are answering it wrong or not, you are not able to answer, I will consider it. But any basic concept, strictly they do. Actually, they will then focus you only about the basic. As sir already said that you will have sequential questions.
Take this interview very seriously, mock interviews very seriously, because mocks will change the game.